From Back to the Future to Interstellar, time travel has always captured our imagination. But what if it wasn't just science fiction? What if traveling through time, forward or backward, was theoretically possible? Scientists say it might not be as impossible as we think. Let's explore the real science behind time travel. Time travel isn't just a fantasy, it's a serious topic in modern physics. Albert Einstein's theory of relativity laid the foundation more than a century ago. It showed that time isn't constant. It bends and stretches depending on gravity and speed. In other words, time is flexible. And under the right conditions, it might just be manipulated. The science of going forward in time, traveling into the future, is not only possible, it's already been proven. The effect is called time dilation, and it happens when you move close to the speed of light. According to Einstein's special relativity, the faster you travel, the slower time passes for you compared to someone standing still. This isn't theory, it's been observed. Astronauts aboard the International Space Station experience time slightly slower than people on Earth. In 2019, NASA calculated that astronaut Scott Kelly, after spending nearly a year in space, aged about 5 milliseconds less than his twin brother Mark. That may sound tiny, but it proves the principle. Traveling at extreme speeds can push you forward in time. If we ever develop spacecraft capable of near-light speed travel, passengers could return home to find that centuries have passed on Earth. That's time travel to the future, and it's 100% supported by physics. The real problem, going backward traveling to the past, however, is where physics gets messy. Einstein's equations allow for mathematical scenarios called closed time-like curves, where time loops back on itself, theoretically letting you revisit earlier moments. Some physicists suggest that wormholes, shortcuts through space-time, could make this possible. In 1988, Kip Thorne, a Nobel Prize-winning physicist and consultant for Interstellar, showed that if a wormhole existed and could be stabilized with exotic matter, it might act as a time machine. But there is a catch. Exotic matter with the necessary negative energy density has never been observed. And even if we could build such a wormhole, it might collapse instantly or destroy anything that enters it. There is also the grandfather paradox, the famous thought experiment. If you go back in time and prevent your grandfather from meeting your grandmother, would you still exist? Physics doesn't like paradoxes, and neither does reality. Quantum theories of time. Quantum physics adds another twist. Some interpretations, like the many worlds theory, suggest that time travel might be possible, but not in the way we imagine. In this view, if you travel to the past and change something, you wouldn't alter your own timeline. You'd create a new one. Essentially, you'd be moving between parallel universes rather than rewriting your own history. It is an elegant way to solve the paradox problem, but there is still no experimental evidence for it. Black holes. Nature's time machines, another candidate for time travel, already exists. Black holes. Near a black hole, gravity is so strong that time slows dramatically. To an outside observer, someone orbiting near a black hole's edge would appear frozen in time. For the traveler, only minutes might pass while thousands of years go by in the universe outside. In fact, this exact concept was dramatized in Interstellar, based on real calculations from Kip Thorne's equations. The closer you get to a black hole, the more time bends. So yes, in a sense, black holes already are natural time machines. They let you move forward but never back. The final verdict, so, is time travel possible? Technically yes, to the future, through the laws of relativity. But traveling to the past remains speculative. It might require technology or physics we don't yet understand. Even if one day we master time manipulation, paradoxes, quantum uncertainty, and energy limits could keep it out of reach. But what's certain is this: the universe already plays with time. Gravity slows it, speed bends it, and space can stretch it. Maybe time travel isn't about building a machine, maybe it's about understanding how to ride the waves of time that already exist.